Next, we're going to be looking at some of the negative aspects, some of the detriments to cabling as far as carrying data signals. The first issue we'll be talking about is attenuation. Attenuation is the degradation of the signal as it travels over distance. The longer the distance, the more attenuation there is. So a very strong signal, very square, binary 1-bit on your cable at transmission point begins to look like a rounded hump, and it doesn't have the same amplitude over distance. So this is resistance, it's capacitance, it's inductance, and it basically degrades the signal. In other words, the receiver can't recognize whether or not this is really a 1 or this might just be some noise or interference on the wire. And as a result, your data begins to get corrupted. Another negative aspect to cabling is crosstalk. Crosstalk is where we have generally parallel runs of wires, cables. And remember how I described the electron flow down the center of the cable and how it propagates a magnetic field. Even with coax, there's a magnetic field of some value around the coax cable itself. Well, if I have parallel wires running side by side, the magnetic field produced by one cable induces electron flow in the adjacent cable. This electron flow in the adjacent cable is interference, and it's actually going to degrade the quality of the signal in that adjacent cable. So again, it causes data corruption, it causes attenuation, and this is crosstalk from parallel cable runs. Again, the most susceptible to this is the unshielded twisted pair, the UTP, because it only has a wire wrapped around the data signal, and that doesn't provide a very cohesive, consistent shielding.